Hello guys, let's welcome to our channel Just Genius. In the last tutorial we have discussed some problems on this Bigoh notation. Now we are going to look some more problems related to Bigoh notation. Let us start our video now. So if you see the example 3, so it says that we have to find upper bound of a running time for a quadratic function. First you have to identify which type of function is given. So it is quadratic function is given here. So given is an upper bound. So upper bound means you have to recall it is related to the Bigoh notation. We can use upper bound in this Bigoh notation. Okay. So f of n equals to 2n square plus 3n. So you have to recall two equalities in the Bigoh notation. Those are f of n less than or equal to c into g of n, and for n greater than or equal to n naught, and f of n equals to Bigoh of g of n. Means when this condition is true, so then f of n equals to Bigoh of g of n. Okay, so let us solve this problem in by the definition of the Bigoh notation. Okay, so given f of n equals to 2n square, I will say 1 second, 2n square plus 3n plus 2, 2n square plus 3n plus 2. First you have to know that f of n equals to c less than or equal to c into g of n. So substitute the value of this f of n so that it becomes less than or equal to c into g of n. So so you have to substitute g of n value. I told in the previous video while solving second example, that is linear in this is quadratic form, that is a linear form. So in the linear form I have taken g equal to n. Here it is in quadratic form, I have to take g of n equals to n square, because we have to take highest term g of n equals to n square we have to take. Okay, we have to take highest power term, highest degree term for the g of n. Okay, 2n square plus 3n less than or equal to c into n square. Okay. Okay, now you have to put the c value so that this value becomes less than this value. I'm going to say one trick to put the c value directly without substituting 1 2 3 4. First add these two, 1, so this one, 2 plus 3 plus 2 plus 3 plus 2, you have to add, you will get 5 plus 2 7. So substitute c value equals 7 here. So n square plus 3n plus 2 less than or equal to c into n square. So substitute c value equal to 1. I told you trick, c value equal to 5 7, 3n square plus 2 7n square. So substitute n value equal to 1 now. So 2 plus 3 plus 2. So this value becomes 7. This value becomes 7. 7 equals to 7. So this condition is satisfied. For n value equal to 1 and c value equal to 7, this condition becomes satisfied. So f of n equals to c into g of n. This condition we got. So you can substitute, you can know that you substituted c equal to 7. Okay, you substituted c equals to 7, n equals to 1. Okay, so if you substitute c equals to 8, it is okay that you will get exact answer, because you have to substitute the value which is greater than c. So we got 7 equals to 7. You can substitute c equal to 8, you can substitute 9, you can substitute 10, you can substitute 11. So you have to substitute value of the c like that, greater than 7 value for n equals to 1. Okay, so that n, so that we can write n greater than or equal to n naught. N naught becomes 1 because we have substituted n equals to 1, that is becomes n naught. So that is n naught. So c value becomes 7. At the particular value of the 7, the condition becomes true. Then we know that f of n f of n equals to Bigoh of g of n. So we have substituted in the place of g of n square, so answer is n square. This is answer. Okay, so once we can look into this, once we will revise. Question is given, you have to find upper bound runtime for this function. Okay, 2n square plus 3n plus 2, you have to find upper bound runtime. If you find how to find upper bound, then here upper bound you have to recall it is a Bigoh notation. Then you have to get the two equations in your mind, that is f of n and this f of n, these two, this condition also. If you substitute value of f of n, if you substitute the value of f of n here, so substitute g of n equal to n square, because highest term degree you have to substitute, that is n square, because it is a quadratic function. You have to substitute g of n equal to n square. In the linear you have to substitute g of n equal to n. In constant you have to substitute g of n equal to 1. Before, if the question is given like cubic, you have to substitute g of n equal to n cube, like that you have to substitute. So you will get like this. So substitute the value of so substitute this value of c. So if you substitute the c value, you will get I have substituted c equal to 1. I told you a trick how to find the c value without looking 1 2 3 4 like that. So substitute this the c value. Okay, c value, here we have substituted c equal to 7. For the 7, the condition becomes true. Also you can substitute the value greater than 7, you have to substitute. You cannot substitute the value less than 7. If you substitute in the place of here, in the place of 7, if you substitute 6n square like that, if n equal to 1, then answer becomes 6. Then 7 less than or equal to 6, then condition becomes false. So you cannot substitute value less than 7. You have to substitute value greater than the 7. So c equal to 7 you have substituted for n equals to 1. So the condition becomes n greater than n naught, n greater than or equal to n naught. So when you draw the graph here on your x-axis you will take size, input size, and y-axis you will take time. So this is c into g of n. This is f of n. For some particular value, c into g of n dominates f of n. So this is n naught. N naught we got equal to 1. So n greater than or equal to 1. Understand? So you can substitute the value of n equal to 1 or greater than 1. I hope that you have understood how to substitute c value and n value. So finally, if the whole condition means this condition is true, f of n less than or equal to c into g of n, this condition is true, then becomes f of n equals to Bigoh of g. Then this becomes f of n equals to Bigoh of g of n. You have substituted g of n equal to n square, so answer becomes Bigoh of n square. This is by the definition of the Bigoh notation. If you look into this by shortcut, shortcut. Given f of n equals to 2n square plus 3n plus 2. I told first rule, drop constant terms. So drop constant, 2 dropped, so it becomes 2n square plus 3n. So next, drop lower order terms. Lower order terms means second. Drop lower order terms. So if you drop the lower order terms, now also so you can say that drop coefficients. Drop coefficients. No, wait. This is drop constant coefficient. Drop constant coefficients. Okay, so that next 3 can be dropped. Next, drop constant terms. Once again, n can be dropped. Next, drop the coefficient, so then becomes 2n square. Next, plus n. Next, drop constant terms. Once again, n can be dropped. Next, you can drop the lower order terms. Next, 2 can be dropped. Okay, understand? So answer becomes f of n equals to Bigoh of n square. So this is the final output we have got. This is the final output. We can find this by the shortcut method. First you have to drop constant terms, next coefficient terms, means that is a lower order terms. When compared to, how can I drop lower order terms? When compared to n square, 2 is very lower than n square, so we can drop the 2. So it is a lower order term when compared to the n square, so drop this term. So this is example number 3. So when we look into the example number 4, so I will show the example, another example. So this is example number 4. So when you look into this example number 4, similarly you can find this is a cubic function. So given function is cubic function. When you look into the example, so you can solve this Bigoh notation. This is a homework once you get. So answer is Bigoh of n cube. You will get Bigoh of n cube. If you solve this, you will get how to solve problems related to Bigoh notation. Okay. So Bigoh, not Bigoh of n, Bigoh of n cube. Okay. So I want to teach you one thing, that once listen, just wait. This is homework, note it. Just wait, I think this is very important. Remember, previously I have taught an order to you like that, like this. If you don't know, please watch that video once. 1 less than log n less than root n less than n less than n log n less than n square less than n cube less than dot 2 power n less than 3 power n, so on. So I have taught you this order. So why I am going to teach this order once means, so when you look into this order, so n square value becomes here, n square is here. You can substitute in the place of n square n cube, because Bigoh notation is an upper bound notation. You can substitute any value of this n square upper value of this n square. N square you can substitute n cube or any value like this one, 2 power n, 2 power 2. You can substitute here. I can substitute n cube. This is also correct answer. So n power 4 also correct answer, n power 5 also correct answer, because if I substitute in the place of n square, if I substitute Bigoh of n cube, it becomes the correct answer. So any value if I substitute from this side, from this right of this n square, it becomes true, because all values are upper bound of this n square. So Bigoh notation tells about this upper bound of this n square. So that's why Bigoh notation is an upper bound. Similarly, you can substitute any value from there, from questions. Okay. So this is, remember this order, you can substitute any value of this Bigoh notation. Okay.